Hello and Assalamu alaikum. Today I'm presenting you the mathematical formulations of LPP. My name is Amal Abdul Rahman and I am from class BSc 4B. Now, starting off with the presentation, first of all, we should know that what actually LPP is. The question that arises is what actually LPP is. LPP is basically a process of finding out an action of a specified plan. A plan would be specified to you, and you have to find an action for it. LPP basically stands for Linear Programming Problem. Linear programming is a technique for finding out an optimal schedule of activities that are independent of one another and keeping in mind all of the available resources that we have. Now, proceeding ahead, two or more variables that are in linear relationship are directly or precisely proportional. The general LPP optimizes a linear function of variables called the objective function, subject to a set of linear equations and or inequalities called the constraint or restrictions. Now, proceeding ahead with the presentation, I would like to present the steps for the mathematical formulation of LPP. That how do you solve the LPP? So, starting off, the number one step is that you have to identify the variables in the question by reading and analyzing the question very thoroughly and very properly. So, basically, read the question and you identify whatever your decision variables would be. You can name the decision variables up to your choice. It can be x1 and x2, it can be x and y, it can be a and b, it can be any variable up to your choice depending on the question. And it can be more than two as well depending on your question. So after you're done analyzing your decision variables, we proceed ahead to step number two. Now, step number two is to formulate the objective function that is to be optimized as a linear function of the decision variables that you've come up in step number one. So basically, you're going to use the decision variables that you use in step number one to formulate the function that is to be optimized. It can be either maximized, it can be minimized according to your question. So you would write the function in terms of z equals to ax1 plus bx2. Now, x1 and x2 are your decision variables that you came up in step number one, and a and b are the constants that will be related to your profit, which we will discuss ahead when we will be looking upon an example that I will discuss ahead. Now, looking upon step number three is that we formulate the constraints of the problem, such as resource limitations or market conditions, interrelation between variables, and other as linear equations or inequalities in terms of decision variables. Now, basically, we write down equations. We write down equations of inequalities, basically. So, always two equations will be made depending on your variables, obviously. So let's say if you have two variables, so our equations would be ax1 plus bx2 less than equals to s, cx1 plus dx2 is greater than equals to t. Now the confusion arises that do we use less than equals to sign or do we use greater than equals to sign? Now you have to carefully analyze the question, read the question thoroughly, and identify that whether the question is of maximize or minimize. If the question says that it is of maximize, then the sign would be used of lesser than equals to in both the equations. But on the other hand, if the question says minimize, that you have to minimize, the symbol would be used of greater than equals to. Keeping in mind, x1 and x2 are your decision variables, whereas a, b, c, d, s, and t are your constants that will vary question to question. Now, the last step that is that we have to include non-negativity constraints so that the negative values of the decision variables are not included. Basically, that they do not have any physical interpretation. So whatever the negative values would be there, they would be eliminated. So you just have to do what you have to do is you have to write your variables, the decision variables, and you have to do it that, for example, you have your decision variables as x1 and x2. So you're going to write as x1 greater than equals to 0 and x2 greater than equals to 0. This means that all of the positive values would be included of your decision variables and all the negative values would be eliminated this way. Now we have an example question in front of us. A firm manufactures the products, each of which must be processed to two departments, Department 1 and Department 2. Now, as you can see that we have two departments, Department 1 and Department 2. And we have two products, product A and product B. So Department 1 for product A is 3 hours per unit, works 3 hours per unit. And for product B, it works 1 hour per unit. And the total weekly labor capacity of Department 1 is 120 hours. And it cannot exceed than this. Whereas on when we're talking about Department 2 for product A works 4 hours per unit, and for product B, it works 6 hours per unit. And the weekly labor capacity of Department 2 is 260 hours, as you can see, and it cannot exceed than this. Now, proceeding ahead with the profit generated by product A and product B. The profit by product A is $5 per unit, whereas for product B, it's $6 per unit. Now, how do we solve this question? What will be your decision variables? What will be your constants that will be used in further equations? Let's proceed ahead and see. Now, the step number one is that you read the question thoroughly and identify the decision variables. Now, as you can see, we came up with two decision variables that are x1 and x2. That represents what? That represents product A and product B. So basically, product A and product B are your decision variables that are depending on the profit. So that is why they are your decision variables that depends on the profit. So we named product A as x1 and we named product B as x2. Now, step number two is to maximize. Since the question was of maximizing, so we would write the equation as we would proceed ahead with maximizing. Now, the equation would be in terms of z equals to ax1 plus bx2. Remember? So over here, A and B are your profit. So whatever the profit would be of product A would be the constant for x1, and whatever the profit would be of product B would be the constant for x2. As you can see, the equation is 5x1 plus 6x2, the same as the profit, 5 and 6. Now, proceeding ahead, step number 3, that we have to write the inequality equations. That is made from the, as you can see, that Department 1 works 3 hours per unit for product A and 1 hour per unit for product B. And it cannot exceed 120 hours. So the equation would be 3x1 plus 1x2 is less than equals to 120, as it cannot proceed than 120 hours. And remember, I told you that whenever we are talking about maximize function, the symbol would be used would be less than equals to. Now, for the next equation, it's exactly the same thing that we will look upon Department 2. 4 hours per unit for 4 hour per unit for the product A and 6 hour per unit for product B. And the total capacity, weekly labor capacity is 260 hours and it cannot exceed than this, right? So it will be 4x1 plus 6x2 is lesser than equals to 260. These two equations would help us find out our variables x1 and x2, which would lead us to this equation and help us find out the profit. Now the last step is non-negativity, that we only have to write down our variables and eliminate the negative part. So we will write x1 is greater than equals to 0 and x2 is greater than equals to 0. This way, all of the negative values would be eliminated and only positive values would be counted. Also, there's one more thing that I would like to add, that let's say if it would have been another department, let's say Department 3 over here, so there would have been 3 equations over here. But we would discuss ahead in later classes. So for now, we only have discussed this way, and this is how we formulate the LPP. How do we solve it? We will discuss it later on later classes. So thank you so much.